Welcome to SUSECon Tutorial 1201. I'm Samuel Snow, joined by my colleague Brent Griggs. As members of the SUSE consulting team, we collaborate with customers on real-world projects. Our goal in this session is to highlight Multi-Linux Manager features that help customers better manage their SLES for SAP solutions. SUSE supports several high availability solutions for our SLES for SAP platform. The goal of high availability is to eliminate single points of failure in order to maximize uptime while protecting your data. Two core components in an SAP environment are SAP HANA and ASCS. SAP HANA is a database management system that stores data in memory. ABAP Central Services, or ASCS, is a core application service for SAP Applications. In an SAP environment, the downtime of either of these business-critical components could be catastrophic. SUSE supports pacemaker solutions that work to eliminate single points of failure for these components. These solutions are validated with SAP and are supported on several platforms. There are many challenges to properly managing these types of systems. Some of these challenges are typical to any OS management in any enterprise environment. However, due to the additional HA components and the complex configurations, even simple management tasks can be much more complicated. Additional to tools provided by SUSE's SLES for SAP platform itself, SUSE Multi-Linux Manager provides several useful features that improve your ability to manage these systems. Today we'll be discussing and demonstrating many of these features.
Multi-Linux Manager. This was previously known as just SUSE Manager, or SUMA for short. It allows you to manage the OS layer from various Linux distributions from a centralized platform. It includes software management, configuration management, and other features. It's going to put every one of your systems into a Postgres database, allowing you to query the system's configuration as well as software errata. And in the rest of this presentation, we're going to be going over many of these features that you see on this slide. One of the important pieces of managing your SAP deployments will be image management, especially in the public cloud, where you're either going to be deploying from the marketplace, or if you would like to be able to provide your own custom images, that's where you can take advantage of SUSE Manager here. The first part is open source tool Kiwi. It is an open source project that allows you to build image files from scratch based on an XML description. Below that, we have the utility KEG. And KEG is actually a tool as well as a GitHub repository of recipes. So the KEG tool is going to utilize those recipes that SUSE team uses to build our public cloud images. You can then edit those KEG recipes to add or remove packages, configure it to your levels of security, and to build utilizing the exact same repositories that your existing systems are using. And how this integrates into SUSE Manager, Multi-Linux Manager can deploy a pre-configured Kiwi instance using SALT. Then you utilizes the activation keys and the CLM repositories to build those recipes using the same repositories as your existing systems. So here we're talking about our Kiwi build host. And just note that the build host needs to have the architecture and OS type as the image that you intend to build. During the client onboarding, you'll be able to check this box, which will deploy a pre-configured Kiwi OS instance on that system. It's also going to allow that system to recognize it as the build host for the further integration, building using SUSE Multi-Linux Manager. Once it's integrated, here's an example of what it would look like in the web UI to build a new image utilizing one of the cloud recipes.
The purpose of this section is to demo how you can configure a build host and put the recipes from our public cloud project to build your own images using your own CLM repositories. So first thing, we've already discussed, you need to have your target OS, you need to have a build host that matches that target. In this case, I've pre-configured or provisioned a SLES 15 SP5 system. We are going to need to provision that system though. We're going to do that through the bootstrap. So let's go into under Systems, Activation Keys, Here I've got an activation key. I've called it build host. Got the necessary channels. Note that I do have the package hub as required, because that's where the keg utility is going to be found. And most importantly, I'm checking the OS image build host button. Selecting that is what's going to use Salt to install a pre-configured Kiwi instance that is integrated with SUSE Manager. So let's utilize that here and curl that bootstrap script in and bootstrap this. Okay. Now, let's go. We should have a salt key that needs to be accepted. Okay, that's pending. Once we do that, I have to give this a minute as our system list. We will keep refreshing this. There we go. Our system is in there. Let's wait until we see all the repositories. All right, our channels are there. We are good. Okay. To make a better presentation here, I do have a script that will help with this. First thing, let's validate that Kiwi is installed and what version that is. It was installed. Let's install our keg tool. Okay, our package is going to be installed. Let's say yes. All right. Let's make a directory for our project here where we're going to keep our recipes. Let's call that SUSECon25. Let's change into there. We're going to need to clone these from the upstream project. So here I'm going to do a git clone. All right, so let's see what we have here. We see that there's a lot of files actually under data and images. Here I'm going to use the -L for the keg utility. I'm pointing the recipes root to the current keg recipes directory in that SUSECon25 folder. And there are a lot, and it errors out because if anything that is just using a symlink to a parent kind of throws some weird errors. But we're going to grep on what our desired target is. Here's SLES 15 SP5-SAP system. Okay, we can ignore these up here at the top. What we were searching for, drag this over to make it a little readable. We see here cross cloud and we have single cloud. If it's specific to Azure, in this case large instance and very large instance, they're going to be in the single cloud. But cross cloud, these are the same recipes that we are utilizing to build across Azure, Google, and AWS. It's the same recipe. But at the time that you are building it, you will have to specify a profile option of which one you're trying to target. But it's the same recipe across, with the exceptions of these Azure large and very large instances. So we're going to make a destination directory for our modified recipe. Now we need to create the actual recipe. So let's break this command down. So once again, our recipes root, that's our local, or that is that keg recipes folder in the SUSECon that we mirrored down using git clone. We're choosing this cross cloud SLES for SAP, bring your own subscription, 15 SP5. Our destination directory is the folder that we just created a minute ago above in the command above, and our format is XML because that is what Kiwi is going to build. Okay, so now we've created that. Let's cd into that folder. Let's see the files that it created. We see that we have our Azure tar. We have the multiple tarballs, and so when we specify what kind of profile we want, it's going to utilize whichever matching tarball that is. That'll be important later. Our Kiwi config, that is what we're going to edit right here. So the Kiwi configuration by default is intended to work with our open build service. Since we're utilizing this with our SUSE manager, we're going to need to put the SUSE manager's public key so that we can access that. Now I am just going to take that and I am going to copy it into my buffer. Let's edit that file. I am looking for the bootstrap section. That's where I'm at. I'm going to add a line here. I'm going to save that. And we're going to need to edit our recipe here. This is where this could be you're removing packages because they're not needed in your environment, part of your hardening process. In this case, I am removing something that's just an artifact. YAST2 _SAPTOOM. There is no longer a YAST2 module in 15 SP5. So this was valid in previous versions, and there's an overlay of SP, actually of just SLES 15 since GA. So in this case, I'm going to remove those 3 lines. You would have a build error if you tried to build with that. But I could be removing other packages here if I didn't want those to be in. Okay, so we've built that. Now we need to utilize it. Okay, now at this step, we've got our build host configured, we've built our image, or we prepared our actual profile that we want to build with. Now we need to work inside the web UI to consume it. So under the images section, if we go in here to profiles, we're going to need to create a profile. So I'm going to just call this and we are going to change that. We're not building a container, we're going to build a Kiwi image. The URL, this is where we need to give it the full path. It is on the local server, so we just need the path to the folder where we created this Kiwi config. Now, I showed earlier that we had multiple tarballs we could actually build for AWS or Google Cloud, but in this case we're building for Azure. That's my lab environment. So we're going to add a Kiwi option of a profile for Azure. Now the key we want, let's see, let's use that. I'm going to point this to my main repos at this moment. And that's really all we need. So if we create this, I now have a profile that I can then use to build images. So I'm going to select the profile that I just created. I'm going to choose my build host. I can rename this, but right now I know this was my Kiwi host that we just did in the earlier step. We see that we're going to build it using that activation key in the following repositories. We can kick this off. And this will take quite some time. In order to check the progress of this, I can select the image that I'm wanting to find out about, and we just see right now that the build is in progress, and we can refresh it. But if we go back to the image list, we can look at one that was built earlier, and then we could see the build status. You could see what Kiwi was actually going through. And you may have to troubleshoot. You may have selected packages that are in a sub-channel and you did not have that as part of your CLM project. This is the other thing. You are going to be able to compare an image for patches that are available, for packages that needed to be upgraded. Or this is to inspect the packages that are in it, but you can actually check if your image is going to be, if you were to build it, or if you were going to deploy this, you would see that this is actually already in need of being patched. So you would want to rebuild this in order to address this. But this is a very nice feature of you're now in control of managing your errata, both unbuilt and systems that are deployed. It will take quite a while, so I think this is the best demonstration that I can do is just show you that that's how we would build it, and here is a result of a built image using the same profile.
When you deploy SLES for SAP HA solutions, it's best practice to use some form of deployment automation due to the complex nature of these configurations. Automation ensures that you have a repeatable process for deploying these systems in test and production environments, and is important to help you start with systems that are closely configured to official setup and best practice guides. SUSE Multi-Linux Manager supports SUSE-provided salt formulas that can help with configuring HANA and ASCS solutions. There are also community Terraform and Ansible projects that can be a great starting point for your deployment automation. Here is a screenshot showing the configuration form for the HANA formula within the SUSE Multi-Linux Manager web UI.
This section is the very important section of managing the content to the repositories and strategies for how you can control when and what patches get applied. We have the ability to control what we synchronize. You put your credentials in, your mirroring credentials, and you connect to the SUSE Customer Center, and you easily select which channels that we're going to mirror down. SLES 15 is modular based, so everything is going to be in a sub channel underneath. Like SAP Applications 15, we're going to choose the individual modules. You can choose, so for example, to not, as we've selected here, waste space with the package hub, or if it was required, you can add those and make sure that the needed software is there.
Here's an example that illustrates a difficult problem with enterprise package management. In the example, a non-production system is patched on Monday to the kernel version ending in 33.1. However, the official repository is updated on Thursday of the same week with a new kernel version ending in 38.1. On Saturday, the system admin applies the latest patches and finds that they've installed the version ending in 38.1 instead of the 33.1 that was applied on the non-production system. In other words, the production server has now been patched with packages that have never been tested. Multi-Linux Manager has an important feature called Content Lifecycle Management, or CLM, that is a solution to this problem. CLM allows you to create custom repositories that are locked in time. Custom CLN repos are organized by projects. Within a project, you define the source channels with their corresponding repositories. You are then able to attach filters to deny or allow packages based on various filter criteria. You can create multiple environments within a project so that you can lock in a custom repo build and only promote builds to another environment when you are ready. When used properly, CLM helps you ensure that you never have packages reach production that weren't already tested thoroughly and allows for granular customization. I'll be demonstrating this process in more detail in a few minutes. One challenge for business-critical systems is finding the downtime to apply patches. Kernel live patching is a SUSE solution that allows you to apply kernel patches to a running system. This enables you to patch important vulnerabilities outside of planned maintenance, as well as increase the frequency of planned maintenance itself. The diagram on this slide shows an example of what this looks like, and we'll be going into a demonstration as well. Multi-Linux Manager, combined with the mentioned CLM feature, allows for a more controlled management of live patching. This is done to ensure that the process works as intended, and that patches that require a reboot are only applied when you desire to do so, while maintaining consistency. For this demonstration, we will be walking through the process of building a CLM project for live patching. First, we have navigated in the Multi-Linux Manager web UI to Content Lifecycle Projects. Note that the project and environment labels will be prefixed to channel and repo labels, so it's best to keep them simple yet distinguishable. Next, we will attach the channel sources to the project. In this case, we'll be selecting SLES for SAP 15 SB5 pool, which is the base channel. And then we will select the appropriate child channels. There are mandatory channels, recommended channels, and we will make sure that we have live patching, public cloud, and we're just going to add all of our channels aside from the package hub channels and some desktop related channels. And we'll select to save. Next, we're going to attach some filters. In this case, we're going to quickly build a date filter. And under filter type, we will select patch issue date and navigate to our desired date. And we want the rule to be deny. This means that any patches newer than this date will be filtered out of our build. Next, we'll create our project environments. In this case, we'll keep it simple and just have our non-production or non-prod environment, as well as our production or prod. For flexibility purposes, we will also be creating a reboot environment, and I'll explain why we want this environment in a bit. Now I'm going to go ahead and trigger our first build. For convenience, I've sped up the footage a bit. This initial build will usually take several minutes. Note that this isn't actually creating copies of the packages themselves, so it has little effect on disk space. As you can see, when a build is finished, you can then trigger to promote the build to the next environment as desired. The actual systems that are going to be managed are subscribed to the corresponding channel environments. In this case, we would make sure to first patch and test our non-prod systems before promoting to our production systems environment. Since the environments can only change when we build or promote, we have essentially solved the problem we talked about a few minutes ago. So before we've added a date filter in our current builds, but now we're going to add filters specific to live patching. CLM comes with some filter templates, so here we'll use the template for live patching. Notice that you can select the kernel by pointing at an already existing system, or select a kernel version from one of your products like we're doing here. And in this case, we're going to select the kernel that ends in 68.1. Now, it's created 3 filters. On the left, we've created 2 deny filters. These filters ensure that any packages that require a reboot are filtered out of our build. This includes kernel and non-kernel packages. And on the right, you'll notice that we've created an allow filter. This will allow back in the specific kernel version that we selected. We've now made it much easier to control our kernel versions. Essentially, we've made it so that systems subscribed to this build aren't going to accidentally install a different kernel. This puts all our systems in sync, consistently locked to this kernel version ending in 68.1 with its corresponding kernel live patches. For the sake of this example, we'll assume that our non-prod and prod systems have previously been patched and have been rebooted up to this point. So with these new filters in place, we're going to go ahead and build to non-prod. Now, we'll also assume that non-prod patching and testing went fine, so we'll promote it to production as well. Note that we will not be promoting to the reboot environment. Now we're in our non-reboot patching cycle. So for the next several months, we will only need to update the date filter, build, promote, and update our systems. So the systems will not need to reboot after applying patches, but will still be taking advantage of our kernel live patching as well as other updates. Quarterly or semi-annually, we'll complete a reboot patching cycle. So we'll simply detach the filters for live patching, attach the desired date filter, build and promote. Sometimes a system may be a new deployment, or for some reason it may be out of sync with the rest of the project. So to allow for flexibility in these situations, we've created that reboot environment at the bottom of the project. Again, this environment is only promoted to when we detach the live patch filters. This way we make sure that important updates that require a reboot outside of kernel updates are applied at least quarterly. Again, this is also important for upgrade situations or any time a system is out of sync with the rest of the project. And in these situations, you can just subscribe to the reboot environment channels. Patch, reboot, then resubscribe to your desired non-prod or prod environment channels. That way you're back in sync with the rest of the project systems. This is the system view in the web UI, specifically the software channels page. Here you can manually assign your channel selection. As you can see, there are base and child channels that correspond to our CLM builds. This assignment can be done manually during registration and can also be done en masse via the System Set Manager. The goal is to set the channels and change subscriptions as little as possible. The content in the channels themselves change as we build and promote, but the channel configuration on the systems should remain static. Client system patching itself can be triggered remotely via the web UI or manually via the system itself. Now, this can be done en masse and in an organized way using System Set Manager and systems groups. Here I'm just demonstrating how you would detach and change filters as you progress through your non-reboot patching or reboot patching cycles. Here's a terminal to one of our clients. I'm going to go ahead and list the repos. As you can see, the CLM project and environment are prefixed, and this system is attached to our reboot environment. We'll run zipper patch to trigger patching here. Since the system is on the same network as Multi-Linux Manager, you'll notice the packages are retrieved pretty quickly. But we're going to go ahead and fast forward a bit while packages install. And afterwards, we'll go ahead and trigger a reboot. Now the system has been rebooted. And in the background, we've subscribed the system to non-prod as well. We're going to go ahead and install the kernel default live patch packages here. This installs the necessary tools and the kernel live patches themselves. Now this can be triggered via the web UI as well, and this operation could be scheduled en masse. So we've run the klp status command and we see an output of ready. This means that kernel live patching is ready and active. And a klp-v patches command will show additional details about which kernel patches we're running. In this case, we'll note that it's the initial kernel live patch. The naming convention at the top shows live patch _1 to indicate this. And we'll see this increment as more live patches are applied. Since it's the initial patch, it doesn't currently include any CVEs outside the normal kernel package. The zipper lifecycle command shows when live patch support for this specific kernel will end. In the background, I've updated the build to a newer date and applied patches without rebooting. You'll notice we're still running kernel live patching, and we're on the same kernel, ending in version number 68.1. A uname output currently shows LP here to designate live patching. Now, if we run klp-v patches, we'll notice that since additional live patches have been applied, the number has iterated to 6. So live patch _6. And we're also seeing a list of the corresponding CVEs that are covered. Vulnerability information can also be identified via the web UI. And again, the zipper lifecycle output displays the end of support for this specific kernel. Changing gears a little bit, we just want to briefly mention that SUSE Multi-Linux Manager is also equipped to assist with system upgrades. This includes major version upgrades, for example, an upgrade from SLES 12 to SLES 15. This also includes minor version or service pack upgrades. For example, an upgrade from SLES 15 Service Pack 4 to Service Pack 5. In the web UI, this upgrade option is found at Software, product migration under the system view. As you see in the screenshot, this will display the currently installed products and give you options for target products to upgrade to. You can then select the target product channels as you see here. Then it will give you the option to select the target base channel. So essentially this gives you the opportunity to select content lifecycle management project channels. That's important for production systems especially. Otherwise you might bypass your locked repos and accidentally apply patches that haven't been tested in production yet when you trigger an upgrade. Now the migration doesn't have a rollback option, so snapshots and backups are important. There is a dry run feature that is useful for identifying dependency issues and things of that nature before triggering the actual upgrade. SUSE Multi-Linux Manager is configured as a SALT master and has the capability out of the box to run different management operations on its SALT clients. SUSE provides SALT formulas which can be used to define and deploy certain supported configurations, and we'll show some examples of that in a minute. Now, SALT allows you to also execute remote commands, and several of the web UI operations that we've already seen, such as remote patch execution, is actually using SALT behind the scenes. Multi-Linux Manager also provides the framework to deploy simple configuration files, custom states, and custom SALT formulas. This allows the user to manage and control client configuration files or configuration states and deploy them to your systems. Here's a screenshot of the SALT formulas catalog in the web UI, displaying some of the formula solutions provided out of the box. This screenshot is showing a simple configuration state example. This feature gives you the ability to easily set the content ownership and mode of a file that will be configured on a client system. The feature allows you to update the file content and has some built-in version control as well. These configuration states can be assigned to a system or a group of systems, and triggering the high state will deploy the configuration file to the system, as you can see in the terminal screenshot below. Although this is a very basic example, this can be very powerful, and we'll be showing more advanced SALT states and formulas. SUSE provides a set of formulas that allow you to deploy a Prometheus and Grafana monitoring solution. A VM for SUSE monitoring is prepared and registered to SUSE Manager. The monitoring server formula for Prometheus and Grafana and their configurations are configured via the SUSE Manager web UI. Now, when you run their corresponding SALT states, the system runs some SALT automation to deploy the necessary packages and configuration for the monitoring server solution. This solution integrates with SUSE Manager nicely as well, so that clients and even the SUSE Manager server itself are automatically targeted by the monitoring server. SUSE supports packages that provide out-of-the-box Grafana dashboards. These can be customized as well. There are also several supported exporters for exporting different metrics for different situations and components. SUSE's SAP team has provided some additional exporters and documentation for monitoring certain components related to our SLES for SAP HA solutions. Combined with custom rules and alerts, this can be used to alert when different criteria are met, and we'll be demonstrating what this looks like in a minute. So for this demonstration, we've already set up a VM for monitoring, and the Prometheus and Grafana monitoring formula has already been assigned to the client system. And the states were run to set up all the configuration. Initially, we left all of the settings on default. Now, as you can see in this system property page, client systems can be assigned the monitoring property, which will install the default node exporter. The monitoring server will then automatically target these systems. This monitoring property can be set manually or during system registration. Now, from the browser, you can access the web UI for the Prometheus monitoring server and view the target system jobs and status. From the browser, we can also log into Grafana and see our predefined dashboards. First, we'll select the SUSE Manager dashboard. As you can see, it's configured out of the box to display things such as database operations, Tomcat usage, load, disk and memory usage, and I/O stats. These graphs can be viewed in different ways and can be exported for reports if desired. Moving to the client system dashboards, we can see similar basic metrics for our monitoring client systems. This next dashboard is also provided by SUSE and shows details related to our HANA pacemaker clusters. These metrics include information related to node and resource status, as well as resource configuration, node attributes, and system service status. There are additional dashboards provided as well. Now, behind the scenes in the Sumo web UI, we've configured the Prometheus formula with some custom configuration. This includes some custom system targeting for SLES for SAP HA solutions and specific exporters. We've also created some custom rules. These rules, combined with alert configurations, can trigger alerts related to certain events. For example, we're seeing that a certain system is showing as being down. This can trigger an alert. The configuration for alerts are very flexible, where this could be triggered if a resource changes or if some other metric hits a certain threshold. Alert contact points can be configured as well with many integrations, as you can see here. As you can imagine, these monitoring and alerting features can be very useful, especially for SLES for SAP HA solutions. These metric baselines can be established and compared against high load in order to make appropriate tuning decisions, as well as receive alerts related to the status of specified events.
Our next section is SUSE Trento. The Trento project came about out of analysis from all of our support cases. Our SAP solutions are very flexible in how they're implemented. It's really a set of blocks that you can put together, and you may or may not be following our best practices guides. And then the behavior, you don't know that you're going to experience it if you are not testing extensively. If you are testing only with the initial deployment, you're actually probably not going to have the same behavior that you were expecting. Our Trento project is a very important project. After reviewing so many of our support cases, it is most commonly a configuration issue with HA clusters rather than code issues. And the reason why is that it is a very complex build of many, many layers. So it's very easy to get off from our best practices. The Trento project, it's going to have data collection pieces that are going to run this, store it in a Postgres database. The Wanda engine is going to run checks. These are our known issues. Port this back in a web format that'll give you an overview, and it's going to find anything that doesn't match our best practices configuration. And it's platform specific. So if you are on premise, this is in Azure Cloud or Google or AWS, to enable those specific checks.
I'd like to demonstrate now how our consulting services can help with the ease of the installation of both the Trento server and the clients. This is done utilizing the SALT functionality in the SUSE Multi-Linux Manager. So here an example, our consultant has created these files and customized them for a lab environment, but the same thing can be done for our customers. So there's going to be a couple of folders. You need to serve SALT Trento server. And then under the formula metadata, you're going to have another Trento server folder. So let me show the contents of this. So this metadata YAML that's going to be in the formula, this is what defines a new group where we're going to put our Trento server. The form that you're going to use to populate this is what's going to show up in the web UI and allow you to configure it. This init SLS. Now that is the actual SALT state that does the work. This is what actually will install all the necessary pieces of a Trento. Okay, let's go to the web UI. So in this lab environment, we've actually already done this, so it's working. But you'll see that created this Trento group and server. So when you select this and hit save, this will appear. Now we've already got it here. When you select this, this is where you can populate the information. The next thing to do, if we save this, we would trigger the high state, and this would actually configure the system. Likewise, on our clients, our system list, we have two SLES for SAP 15, SP5, and as a HANA cluster, and we want to check those. It's the same way. Select formula, Trento client, save, Trento client appears. And we repopulate this. You will need the Trento's API key. So you go into settings, there's the API key, copy. You place that in there. Now these two nodes have already been configured to shorten our demo. That brings us here under our clusters tab. While we have our hosts for the individual systems, it's detected these are Azure systems. We go into the cluster. We would make sure all of our checks are enabled. We have Core Sync, OS package versions. We are using SBD, Pacemaker, SAP Miscellaneous. Now, I am not going to enable the Azure Fence agents because I am using our recommendation of SBD. SAP HANA System Replication Resource Agent. This would be the classical SAP HANA SR. So we save the check selection, start execution. And now we come through here and look at our results. We want to make sure things are set. If you wanted more information, we can click on here. It tells us more about what was checked, gives us references to the corresponding information. Let's see if we have any issues here. So yes, we have a warning. This is the lab system. Have not changed the password. It is letting us know. Both nodes did not meet that expectation. Very common. Easy to let that slip up. Another one, multiple SB, both systems. This only has a single SBD device. We recommend having up to 3. So we eliminate a single point of failure. So this is rightfully pointing that out, but this is just a lab system and it was not built with that. But you see all these systems, and so as you integrate these in to SUSE Manager, to SUSE Multi-Linux Manager, and then to your Trento environment, this is going to allow you to periodically check your systems and check and make sure that you are aligned with our best practices and that they are all consistent and you do not have configuration drift. And that's my demo for Trento. I hope you enjoyed. Thanks.